প্ৰিয় শিক্ষাৰ্থীসকল, কৃষ্ণকান্ত সন্দিকৈ ৰাজ্যিক মুক্ত বিশ্ববিদ্যালয়ৰ বিদ্যায়তনিক দৃশ্য শ্ৰাব্য অনুষ্ঠানটিলৈ আপোনালোকক স্বাগতম জনাইছো। স্বয়ংপ্ৰভা DTH চেনেল 20ৰ যোগেদি শিক্ষাৰ্থীসকলৰ অধ্যয়ন কাৰ্য অধিক মনোগ্ৰাহী আৰু ফলপ্ৰসূ হোৱালৈ লক্ষ্য ৰাখি বিভিন্ন বিষয় সামৰি আমাৰ এই বিদ্যায়তনিক অনুষ্ঠানটি সজোৱা হৈছে। আহকচোন প্ৰিয় দৰ্শকসকল, আমাৰ আজিৰ খণ্ডটিৰ মাজলৈ আগবাঢ়ো।
Hello viewers, today we are going to discuss about the topic logic gates. So this topic includes in the first semester of BCA program. So the content of these units are different types of gates, that is NOT, NOR, AND, then XOR, XNOR, NAND, etc. And then we will learn about the conversion of logic gates. So first, what is logic gates? So logic gates are the digital circuits or known as logic circuits, as they can be analyzed using Boolean algebra. It consists of one or more than one input signals and only one output signal. Logic gates are operated with binary numbers, that is 0 and 1. Now, any Boolean functions can be represented in the form of gates. And gates can be represented in three ways, that is graphical symbols, algebraic notation and truth table. So now we going to discuss about the logic gates with their graphical symbols, algebraic notation and their truth table. So first we say the NOT gate. So NOT gate, it is also known as inverter, and the symbol of the NOT gate is represented as so here in the NOT gate there is only one input and one output, and the output is given as complement of input. That means the truth table of the NOT gate is A is the input and Y is the output, and A value can be 0 and 1, and the complement is 1 and 0. So this is the truth table of the NOT gate. That means when the input is 0, output is 1, and when the output is 1, the input will be when the input is 1, output will be 0. Just complement of the input signal. Next, we will discuss the OR gate. The symbol, the circuit of the OR gate is represented as this, and here A and B are the inputs and Y is the output. So OR gate has two inputs or more inputs. We can give 3, 4 like this, and but only one output signal, which is equal to the OR sum of all the inputs. The graphical symbol is this, and output can be represented as A plus B. So the truth table of OR gate is 0, 0. The combinations will, when A is 0, B is 0, output is 0. 0, 1, 1, 0, then 1, 1. So the output is represented as A plus B. So when 0 plus 0, it's 0. Then 0 plus 1, it is 1. 1 plus 0, 1. And then 1 plus 1, 1. So from this truth table, we can say that when any of the input is 1, then output will be 1. Now the OR gate is also represented with this circuit. Here we connected two switch connected in the parallel, A and B, and a bulb is connected, and here we have given a battery. Now when both the inputs are 0, that means both the switches are open, then no current will flow, and then the bulb will not glow. Then when any of the input is 1, that means suppose A is closed and B is open, then current will flow through the switch A, then the bulb will glow. That means it will high. So this logic truth table can be represented with this circuit. Then when both the inputs are 1, that means both the A and B switch are closed, then current will flow and the bulb will glow. So the logic gates of OR gate is represented by this circuit. Now next we discuss the AND gate. This is the circuit of the AND gate. Here in the AND gate has 2 or more inputs and only one output, and which is equal to the AND product of all the inputs. That is, here 2 inputs are applied, so Y is the product of the 2 inputs, that is A and B. And the truth table of AND gate is when both the inputs are 0, the output is 0. Then 0 1, output is 0, 1 0, output is 0, then 1 1, output is 1. So from the truth table, it is clear that if any of the inputs is 0, then output will be 0, because the product output is equal to the product of all the inputs. And when both the inputs are high, that is 1, then we will get the output is high or 1. And this truth table, if we represent in a circuit, in this circuit we connected 2 switches A and B in series combination. So when any of the input is 0, that means if any of the switch is open, either A or B, then no current will flow through this bulb and it will not glow. And if both the switches are closed, that means both are closed, that means the current will flow through the switches and the bulb will glow. So the truth table of AND gate is represented by this circuit, that is inputs A and B connected in series. So I think it is clear now. Next we will go to the NOR gate. Now we will see the NOR gate. So NOR gate means not OR. It has 2 or more inputs and only one output, which is the complement of the OR sum of the 2 or more inputs. Now this is the symbol for the NOR gate, and the output is represented as A plus B and complement of the sum of the 2 inputs. And the truth table of NOR gate, that is not OR, because we have given a circle here, so it shows the NOR gate. In the NOT gate, what we have used, this is NOT gate, that is complement of the input, so we symbolize as a small circle. So similarly, if we put a small circle in the output of the OR gate, we get the NOR gate. Now this is a truth table. Here when both the inputs are 0 0, in the OR gate what we get? We get the, when both the inputs are 0, we get 0, but in the NOR gate we get it is 1, and when 0 1, it is 0, 1 0 0, then 1 1 0, just complement of the OR gate. Now we from the truth table, it shows that when both the inputs are 0, that is low, then the output is high, that 1. In the NOR gate, when both the input is 0, output is high, and if any of the input is high, then output is low, that is 0. Then next we see the NAND gate. So NAND gate is a not AND. Not AND, that means in the AND gate we have to put a NOT gate. So this is the symbol of AND gate, and if we give a small circle here, then we get the NAND gate. And NAND gate is the complement of the AND gate output. So A and B, this is the output of the AND gate, and if we give bar here, then we get the complement of the AND gate. And the truth table of NAND gate is, here it is 1 1 1, then 0. In AND gate, what we have seen, when any of the input is 0, the output is 0. But in the NAND gate, as it is the complement of the AND gate, so if any of the input is 0, the output is 1, that is high. And when both the input is high, that is 1 1, we get the output as 0. So this is the truth table of the NAND gate. Now let us see one example. A truth table, which is, I will draw a circuit here, and the truth table is used to show the behavior of the logic gates. So next we see the XOR gate, which is called the exclusive OR gate, or it can represent as XOR gate. It is also called XOR gate, and the symbol is, so this is the symbol of exclusive OR gate. So here what happened in the truth table, and output is represented as A plus exclusive OR then B, and the truth table is shown as this: if 0 0 0 1 1 0 then 1 1. When both the inputs are 0 in the exclusive OR gate, we will get 0. And this output is also written as A bar B plus AB bar. So this represents, bar means it is a complement of A. So complement of A into B plus A complement of B. And the truth table is 0 1, it is 1. 1 0, it is 1, 1 1, it is 0. So from this truth table it is clear that when both the inputs are same, either 0 or 1, then the output will be 0, that is output is low. And when, if any of the input is high, then output is high. So this is the truth table, and this XOR gate output is also represented with the logic circuits. Here what we have given here, A is the input, and which is applied using a NOT gate to the AND gate. Two AND gates are there, and B is applied, so output will be A complement B. Then here again B is applied using a NOT gate to this AND gate, then A is directly applied, so output of this AND gate is A B bar. And in the output we have used a OR gate, that means it sums both the inputs, so at the Y is equal to this A bar B plus A B bar. Now if we represent the truth table of this circuit, it will be, so let me write here A B A bar B bar, A bar B, A B bar, then we have had this sum A bar B plus A B bar. So first A B is 0 0 0 1 1 0 then 1 1. So when A is 0, A bar will be 1. A is 0, A bar is 1. Here 1, so A bar is 0, 1, A bar is 0. Next B bar, so B is 0, so B bar will be 1. Here 1, so it will be 0, 1, 0. So this is the value of B bar. Now let us see the A bar B. So here A bar is this input and B is this one. So product 1 into 0, it's 0. Then 1 into 1, it's 1. 0 into 0, it's 0. Then 0, 1, it comes 0. Next A B bar, that is A B bar. A, then B bar, so we have to consider this and this. So 0 1, it goes 0, 0 0, it comes 0, then 1 1, it goes 1, then here 1 0, it shows 0. Now we have to add these two figures, that is A bar B plus A B bar. So 0 plus 0, it is 0, 1 plus 0, it is 1, 0 plus 1, it is 1, and at the last 0 plus 0, it's a 0. So it is similar to the XOR truth table of the XOR gate. So now we have seen this 0, 1, 1, 0. So this output value is similar to the XOR gate output. So what we have seen, the XOR gate, which is represented with this symbol, and it has two inputs and two or more inputs and one output, and it is symbolized as this A plus circle, then B, and its output is represented as A bar B plus A B bar. And this formula is again explained with this truth table and from this diagram. So this diagram is equal to this symbol XOR. So this XOR gate is also explained with the logic gate circuit, this one. So here 2 AND gate, 1 OR gate and 2 NOT gates are used. And from the truth table it is same. We have explained from this truth table, it is seen that the output of this gate is equal to this gate. So I think it is clear now. So next gate is the exclusive NOR gate. So here in the exclusive NOR gate, in the XOR gate, if we put a circle here, we will get the exclusive NOR gate, or we can write XNOR gate. So here A and B is the input of the exclusive NOR gate, and the output is represented is the complement of the exclusive OR gate. So here if input is 0 0 0 1 1 0 1 1, and the output is when both the inputs is same. So it is complement, output is complement of the XOR gate. So from this truth table it is clear that when both the inputs are same, then output is high. Means 0 0 output is 1 and 1 1 output is 1. And if the inputs are different, that is if one is high, one is low, then we get 0 output. Just complement of the XOR gate. And output is represented as A B plus A bar B bar. So this is the output expression of the XNOR gate. So now I am again repeating all the gates. So first we have discussed the NOT gate, that is symbol of NOT gate, then A is A bar. So next gate we have seen the OR gate. So OR gate symbol is this A, B and Y, and Y is equal to sum of the inputs of the OR gate. So the third gate we have discussed is the AND gate. So this is the AND gate, A, B, Y and Y equal to A dot B. That means product of the inputs. Then the fourth gate we have discussed NOR gate. So in the NOR gate, OR gate, if we put a NOT gate, then we will get a NOR gate. So here Y is equal to A plus B bar. So this is the NOR gate. First is NOT gate. This one is OR gate. Here it is AND gate. This one is the NOR gate. Next we have seen the NAND gate. If in the AND gate we put a NOT gate, then we will get the AND gate. So AND gate output is AB bar. So this gate is NAND gate. And finally we have seen the XOR gate. XOR gate is symbolized as this, like this graphical symbol. So Y is equal to A plus B. So this is a symbol of XOR gate. And the last gate we have discussed the XNOR gate. That is XNOR gate, and it is represented as so if we put a NOT gate in the output of the XOR gate, we get the XNOR gate. So how many gates we have learned? 1, 2, 3, 4, 6, 7. So these 7 gates we have discussed today. Next, another topic we will discuss now, that is the conversion of the logic gates. So now the next topic is conversion of logic gates. So in the logic gate, its input and output will have one of two possible voltage levels, that is suppose V1 or V2. Suppose we assume that V2 is greater than V1, and it referred to these two voltage levels as high and low. Which is greater we have represented as high and other is low. Now let us take an example of 2 input and 1 output gate, and in order to determine the function of this gate, we must assign the logic values of the gate to our voltage levels. Suppose we get one positive logic. So in the positive logic, the low is represented as 0 and high is represented as 1. And another one is negative logic. In negative logic, the low is represented as 1 and high is represented as 0. Now we see in the voltage level, that is low then high. So it is 0 and 1. So it is a positive logic. So high voltage, that is 4.5 greater than or equal to 4.5 volt, we consider as a logic high, that is logic 1. So it is a positive logic, and in case of negative logic, the high is represented as low and this one is negative logic. So here the low is represented as 1 and high is represented as 0. So this means the 0 means the high voltage and 1 means the low voltage. So this is the difference between positive logic and negative logic. The representation of high and low is different. So the term positive and negative are somewhat misleading, since both the signals or voltage values may be positive or both may be negative. It is not the signal polarity that determines the type of logic, but rather the assignment of logic values according to the relative amplitudes of the signals. So now the rules for converting positive logic to corresponding negative logic. The first is to change AND graphic symbols to OR or vice versa. And then next is to change NAND graphic symbols to NOR or vice versa. And then next is to add circle to the input and output points where there are no circles. And to remove circles at the input and output points whenever there is a circle. So dear learners, today we have discussed the logic gate topics, where we have discussed different types of logic gates, that is NOT, OR, NAND, NOR, NAND, XOR, XNOR, and at the last we discussed the conversion of logic gates.
ইমান সময় আমি স্বয়ংপ্ৰভা DTH চেনেল 20 যোগে সম্প্ৰচাৰিত কৃষ্ণকান্ত সন্দিকৈ ৰাজ্যিক মুক্ত বিশ্ববিদ্যালয়ৰ বিদ্যায়তনিক অনুষ্ঠানটিৰ আজিৰ খণ্ডটি উপভোগ কৰিলো। এই বিদ্যায়তনিক অনুষ্ঠানটিৰ জৰিয়তে শিক্ষাৰ্থীসকল নিশ্চয়কৈ ভালেখিনি উপকৃত হৈছে। পুনৰ আন এটি বিষয় লৈ আমি আপোনালোকৰ মাজলৈ আহিম। নমস্কাৰ।